Hello, and thank you for joining me for this video. This is going to be the first of two videos that I'm making for Unit 4, just the first 3 lessons here in this unit. Okay, so we're going to start off with section 4.1, which has to do with plate tectonics. And this is something that we could spend probably 9 weeks on, but hopefully I'm only going to be spending about 10 minutes just giving you a pretty good overview of what exactly plate tectonics is. So if you remember, the geosphere is composed of the core, okay, which has 2 separate parts to it, the inner and the outer core. And then the mantle, which again has technically about 2 sections as well. And then the crust. So we're actually, for plate tectonics, going to classify 2 different parts here that are composed of the mantle and the crust. So right up near Earth's surface, that's where we are going to be concerned with plate tectonics. So the lithosphere is composed of all of the crust plus a little bit of the outer mantle, which is rigid or solid. Okay, so these are going to form the plates. And then underneath that is the asthenosphere. So it is deep, it's part of the mantle. And it is composed of partially melted rock, so it is a fluid, and as a result of it being a fluid, it has the ability to flow or move. And the movement of the asthenosphere is going to carry the lithosphere plates right on top of it. You can think of it, almost like, I don't know, surfboards on water. Okay, but anyways, within the mantle, okay, where we have this fluid rock because it is melted, we have these convection cells. So convection is a very important concept in environmental science, not just here in the geosphere, but also especially in the atmosphere as well as in the hydrosphere within the ocean. Okay, so what we have is hot molten rock, right, flowing up towards the surface. And as it gets up towards the surface, it cools down, it's going to move laterally. And then as it cools, it is then going to flow back down where it warms up again and then flows up like that. Okay, so these are known as convection cells, and these convection cells are what are moving our plates up here. Okay, so these plates, they don't move very fast, only about a few centimeters per year. Okay, I've seen the comparison of your fingernails grow about the same length as these plates move in a given year. Okay, so if we take a look at Earth as a whole, so just a 2-dimensional map right here, we can see all the different plates as well as the divisions. So there are 3 different types of boundaries that form between plates depending on how they move towards each other. Okay, so again, these plates are floating on top of the asthenosphere. The asthenosphere is moving the plates, and the movement of these plates is what is known as continental drift. Okay, so over time, we've seen the separation of the African continent from the South American continent. If you take a look how closely this plate would fit, this landmass would fit within Africa. So at one point, these were actually together and they've been separated over time, over many, many years. Okay, but at the same time, there are boundaries where 2 plates are coming together, and that's gonna usually form things like mountains or volcanoes. Okay, so again, over time, these plates are either moving away from each other, moving toward each other, or sliding along one another, okay, kind of like in a parallel manner. So the movement of these plates has changed not just the land masses and the shapes of the land masses, but also different features like mountains, ridges, volcanoes, islands. Okay, so if you are interested, you can take a look at this continental drift time lapse, which is actually really cool. It shows you, at least in theory, what the Earth has looked like over the past few billion years. All right, so let's take a look at what some of the different boundaries are. So we have transform boundaries, okay? We have convergent boundaries and we have divergent boundaries. So convergent boundaries are where the two plates are coming together. And typically this is going to cause mountains to rise up or even volcanoes to form. The divergent boundaries, that's when the two plates are moving away from each other. So they're actually moving away. So that's because we can see magma up here pushing up, causing them to move away from each other, and that forms rifts. And then transform boundaries is where they move parallel to one another. So you'll actually be able to see the fault typically. And this would not really contribute to forming anything like a volcano or a mountain. Okay, so divergent boundaries where the two plates are moving away from one another. All right, so we have magma. Okay, so this is liquid rock flowing up and it's pushing the plates apart. And the magma typically is going to harden, become new crust, so actually become part of these plates. And sometimes the magma might even break the surface and cause a volcanic eruption at these divergent boundaries, okay? Now, something that is very commonly seen with this type of boundary are earthquakes, and usually these are going to be occurring in the sea, so underneath water. And when that happens, these plates are moving, that's going to cause kind of like a pushing up of the water, and that's going to result in tsunamis. And sometimes, even instead of magma, if there's water down here, water can actually erupt, very hot water as geysers. Convergent boundaries are when the two plates come together. So in this picture here, we can actually see the one plate moving down below the other plate. And what that is going to do, that's actually going to displace the magma here and push it up towards the surface and cause volcanic eruptions, which will result in the formation of volcanoes in the first place, but also result in volcanic eruptions. So not only that, but this plate moving down here, so that's known as subduction. And that is going to mean that this plate, all right, the rock here is going to eventually start melting and contribute to the formation of this magma. Sometimes if the two plates are coming together, both of them are moving up, all right, that would result in the formation of mountains. And just like with the divergent boundaries, these two plates moving against each other, okay, there's a lot of energy there. Sudden shifts are going to result in earthquakes. And our last one here is transform boundaries, where these two are typically locked together, right? But they're moving parallel to one another. And when one or both of them shift, that is going to release a lot of the energy that has been pent up as they've been stuck within one another. So when they shift, that's going to result in an earthquake, okay, a release of that energy. So these are very commonly associated with earthquakes. So one of the most common examples of a transform boundary or fault is the San Andreas Fault. So that's one of the reasons why there are so many earthquakes here on the west coast of the United States. Because when these plates, when they shift, that's going to release the energy that has been stored up and result in an earthquake. All right, so a little bit of information about the three possible things or natural disasters that can be associated with the movement of these plates. First, we have volcanoes. So again, remember that this is typically associated with the conversion boundaries, okay, when one plate is pushing down on the other and resulting in a displacement of the magma up through the volcano. But remember that it could also happen in divergent boundaries as the magma is pushing up and separating the two plates. Okay, so if the pressure within here, so again, stored up energy, gets to be too high, then the lava is going to be ejected here. So not just lava, so our molten rock, but also ash, lots of carbon dioxide getting pushed up into the atmosphere. Okay, so it's not just going to affect the area around here in the ecosystem here around the volcano. That has the potential, if it's a strong enough eruption, to actually contribute a little bit to climate change. All right, so the more ash up in the air, the less sunlight will get through, and that will cool down the surface. Okay, and again, a release of carbon dioxide will also mean, in a more intense greenhouse effect. Earthquakes, right? Something that's associated with all three of our boundaries here. So again, suddenly shifting plates, because sometimes, especially with the transform boundaries, they're kind of stuck on one another and they're supposed to be moving. And since they're supposed to be moving and they're not, then the energy that is contributing to the movement of these plates is getting stored up until when they finally shift, that energy is going to get released. Okay, so there is what is known as the focus, so where the energy release occurs. And if you look at the surface, okay, right on top of where that focus is, because the focus can be underground, the epicenter is the point on the surface right above the focus. Okay, so earthquakes move in all directions, not just in one. And the Richter scale, which we'll be looking at in our lab this week, is used to measure the strength of an earthquake. It's logarithmic. So what that means is that if we have an earthquake on the Richter scale of 7 and a different one on the Richter scale of 8, that means that the one that was 8 is 10 times as strong as the one that was 7. Okay. And then finally, we have tsunamis. So tsunamis occur as a result of an earthquake that shifts underwater, okay, on the ocean floor. And when the earthquake happens, right, that's going to push up a little bit on the water, and that's going to generate this massive wave or tsunami. And the tsunami is then going to, again, move in all directions. And even though they're called a tidal wave, I want you to make sure, so even though they're called tidal waves, has nothing to do with tides, all right? But these things can move very, very fast. And as they do get closer to the coast, they'll slow down as a result of ecosystems there absorbing some of the energy as well as the continental shelf, but still will bring lots of energy and water to coastal areas. So one of the worst tsunamis in history happened back in 2004 here in the Indian Ocean, and resulted in, again, one of the worst natural disasters in history, killing hundreds of thousands of people as a result of the tsunami. Okay, well, that is all for the plate tectonics section today. So I hope that you were able to take in a lot of this information, make sure that you answer the questions before the due date on Wednesday, and we'll be doing the rest of Unit 4 this week.